presenting a concise overview of our paper, AI-powered digital twins for wireless network optimization. It is a comprehensive survey. Let's start with the big picture. They argue that modern wireless networks, especially the fifth generation and the sixth generation, the emerging sixth generation, have have become too dynamic and complex for traditional, mostly reactive optimization. These networks support complex These networks support massive number of base stations, billions of sessions, dense Internet of Things applications, and rapidly changing traffic patterns due to user mobility and environmental factors. On top of that, 5G introduced major architectural shifts like network slicing, software-defined network, and network function virtualization. While these improve flexibility, they also multiply coordination, complexity across radio access, transport, and edge domains. The paper emphasizes that static models and human in the loop control can't keep pace with millisecond requirements. Here, here where a paper comes in. This is where digital twins comes in. A digital twin is a virtual counterpart of our physical network elements, continuously synchronized with real-world data. In wireless systems that include user equipment, base stations, antennas, radio channels, propagation behavior, code routing functions, and edge computing resources. The key idea is that a digital twin doesn't just experimentation. Some synchronization types. There are four main synchronization types. The first one is temporal synchronization. It's for real-time update, spatial synchronization using geolocation aware modeling, and the state synchronization driven by continuous feed. And the last one is casual synchronization that helps distinguish triggers from outcomes. The artificial intelligence as the engine that turns digital twins into active decision makers. The machine learning models can forecast traffic failures, while reinforcement learning can automate control decisions. Importantly, the digital twin environment allows these learning systems to explore strategies safely without disruption in the live network. So the core thesis is simply simple but powerful. AI enhanced digital twins can move wireless operations from reactive troubleshooting to proactive autonomous optimization, which is essential for 6G scale complexity. With that foundation, we'll now shift to architectures and specific AI techniques that make this possible. Now, my friend Khizer, our next team member,
So,
will
hi, my name is
continue
Momin.
the next topic.
Hi, my name is Momin, and I'll present you the digital twin architectures and also the AI techniques with it. So, picking up from the foundational concepts, I'll walk you through the main digital twin architectures proposed for next generation wireless networks, and also I'll highlight the AI techniques that make this system intelligent. So the survey which we have done outlines several architecture patterns, like the first is digital twin enhanced wireless channel model designed for 6G. In the setup, physical layer sensing continuously. It feeds the real-time measurements like channel state information into a virtual channel model. Also, the digital twin predicts upcoming degradation such as fading or interference and allows operators to test recovery strategies in the virtual environment before applying them on live network. So this will help moving 6G management from a reactive mode to a proactive prediction driven control loop. Also, then the paper in it includes like self-evolving digital twin networks. Like these are built for high autonomy and minimal human intervention. They also combine learning modules that monitor user satisfaction and also like network conditions evolving modules that may adjust topology or parameters. Also, this architecture aligns with the vision of kind of future networks like 6G and all, and then optimize it and self-heal kind of thing in the real time. Also, you can see the digital twin architecture over here. I have given a diagram over here, like we have given some diagrams. Also, the third architecture directional focus on edge integrated digital twins. I mean, yeah, so instead of large centralized twin, multiple digital twin instances operate at different layers on the network, especially at the edge. This helps in reducing the latency of like for ultra responsive services and helps with scalability and distributing workload across local or the regional or in the global circumstances. Coming to the AI layer, the most emphasized technique in the survey is the deep reinforcement learning you can see over here. I mean, which is like a many wireless networks optimization tasks naturally fit into Markov decision process formulation. So here the agent observes network states, traffic load interference, user mobility, and performs actions such as adjusting spectrum allocation or admitting new slices. The reward functions typically combine throughput, latency, reliability, energy consumption, and fairness also. Importantly, the digital twin environment provides a safe sandbox where agents can explore aggressively and train under both typical and rare conditions. Also, the survey, which includes the federated learning, like distributed digital twins, train models locally, and only share weight updates, it preserves privacy actually and reduces communication overhead. Also, neural architecture search is like automatically design. It is a way to automatically design optimal deep learning models for specific digital twin tasks. Though it comes with higher computational costs. So yeah, cost is a man necessary thing to watch out. Overall, the combined architecture and AI approach is like about achieving real-time performance, privacy, preservation, and also scalability. Which, with these foundations set, the next speaker will how these capabilities translate into real applications and challenges. So, Muktadiri, you can go ahead.
Now I'll wrap up the application research challenges and future direction, which are identified in the survey. So, firstly, the paper highlights major use cases where AI-powered digital twins bring measurable values. A central application is resource management for network slicing. The digital twin can maintain virtual replicas of each slice and continuously track metrics such as throughput, latency, packet loss, and resource usage. Using deep reinforcement learning, the system can dynamically allocate resources across heterogeneous slice types like enhanced mobile broadband and ultra reliable low latency communication while preserving services level agreements. Uh, the research suggesting significant gains over static allocation, improves spectrum efficiency, and reduced resources waste. Secondly, spectrum management is another key domain. Digital twins can model real electromagnetic environments, estimate interference, and support intelligent frequency and power decisions. This is especially important in the Internet of Things IoT devices. Thirdly, the survey discussions energy. Thirdly, the survey discusses energy efficiency optimization. Nothing that wireless networks carry major operational energy cost by modeling base station power behavior across active, idle, and sleep modes. Digital twins can predict low traffic windows and coordinate energy saving strategies such as cell sleeping and coverage expansion by neighboring stations. And the last, digital twins enable stronger fall detection and network security. Machine learning models trained on digital twins data can detect anomalies earlier, estimate remaining useful life of equipment, and even stimulate attack propagation to guide containment strategies. And here are some challenges which we faced in our survey: synchronization and latency. If the twin lags behind the physical network, the decision may be based on outdated states. Scalability and computational complexity. Future ultra-dense networks create massive state spaces. Data privacy and security. Digital twins require sensitive user and operational data. Looking forward, the paper highlights promising research directions, including quantum computing for hard optimization problems, cross-domain digital twins integrating sensing, computing, and communication, and stronger explainable artificial intelligence to improve operator trust and regulatory accountability. And now Khizo will go with the conclusion.
So when it comes to the conclusion, the survey has focused particularly on the use of AI to create digital twins intended for the optimization of wireless networks and considered architectural frameworks, AI techniques, uh, one second, like so, like AI-powered digital twin as a key pathway towards self-optimization, proactive and resilient 6G area network, while emphasizing that synchronization, scale, and trust remain the frontier problems to solve. So hence this was a project and the paper. So thank you so much. One second, guys.